Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we go through unique triangles. So what we're after today is I want to be able to give you some dimensions of a triangle, so maybe a side length and some angle measurements, and you tell me whether there is only one triangle you could draw with those dimensions or whether there are infinitely many. So let's start off by looking exactly what I mean by a unique triangle. So it's important to note that when we're talking unique triangles, we consider congruent triangles the exact same triangle. So a triangle is unique if I give you the dimensions of that triangle and there is only one triangle you could draw with those dimensions. Or if you like, if I drew another triangle with those dimensions, it would be congruent to the first. So hopefully this definition will mean a bit more to you as we go on in the video. So just like for congruent triangles, there are tests. We can test to see if a triangle is unique, and you will be relieved to know that the tests are the same as those for congruence. SSS, SAS, AAS, and RHS, okay? But again, the S's and the A's have a slightly different meaning. So here, S doesn't mean that there's a pair of equal sides as it did in congruent triangles. S just means a side length, and A just means the size of an angle, and R means a right angle, okay? So this first one here, SSS, means that you're told the lengths of all three sides. The second one means you're told the lengths of two sides and the angle between. Please make sure you understand it has to be the angle between the two sides you're given. Can't be just any other angle. AAS is, of course, two angles and one side. And RHS is a 90-degree angle, the hypotenuse, which is the longer side of the right angle triangle, and another side. What all these tests mean: if I give you the lengths of three sides of a triangle, it is unique. There is only one triangle you can draw with those three side lengths. For the second one, if I give you two sides of a triangle and the angle between, there is only one triangle that you can draw with those two sides and angle between. If I give you two angles of a triangle and one side, there is only one triangle that you can draw with those dimensions. If I give you a right angle triangle and I tell you the length of the hypotenuse and the side, there is only one triangle that you can draw with those dimensions. Now again, we're counting congruent triangles as the same. So for example, if I told you that I wanted to draw a triangle that has side lengths 3 centimeters, 4 centimeters, and 5 centimeters. So of course I can draw that. It would look a bit like this. It actually turns out to be a right angled triangle. So 5 centimeters is the longest side, and so on. It would look like this. Now, of course, you might have drawn it like this. You might have drawn the 3 centimeter side here, and you might have done that, right? But what I'm saying is, even though these triangles have a different orientation or facing a different way, this triangle and this triangle, they are congruent triangles. So any triangle I draw with these three side lengths will be congruent to this triangle either, so it'll be the same as this triangle. So let's say I told you that I'm going to draw a triangle that has three angles, 60, 60, and 60, all angles equal to 60 degrees. Now I've given three angles. Notice that none of these tests are AAA. AAA is not a test for uniqueness. What that means is, if I tell you I'm going to draw a triangle with three angles equal to 60 degrees, there are actually infinitely many triangles that you can draw. Now, hopefully you know that if a triangle has all angles equal to 60, it must be an equilateral triangle. So I could draw an equilateral triangle with side length of, say, 1 centimeter, and it satisfies this. It has all angles equal to 60. But I could draw an equilateral triangle like this where each side was, say, 2 centimeters. This triangle, the first one and the second one, they are not congruent. They're not congruent because they have different side lengths. So therefore, if I tell you the three angles of a triangle, it is not a unique triangle. There will be actually infinitely many triangles with those angle sizes. For this example, where all angles are 60, you could draw an equilateral triangle with sides 1 centimeter or 2 centimeters, 3 centimeters, 3.2 centimeters, whatever. So that is not unique. So it has to satisfy one of these tests to be unique. So if I tell you information that satisfies one of these tests, there is one and only one triangle you can draw with those dimensions. Any other triangle you draw will be congruent to the first triangle. Now I want to point out that I'm not going through this video on how to construct congruent triangles. Please read the notes I've given you and it will go through how to do that. It's just too hard and I can't really show you how to use the protractor and compass on the program that I'm using. Alright, thank you for tuning in. This has been the luckiest maths teacher in the world. Have a great day.